can we use law of sines? Do we have a pair? Yes. What's slightly different about example 3 compared to the other two? Yeah, I gave you a side this time as the other bit of information instead of an angle. So does that mean we can't use law of sines? Well, no, it just means we have to use it slightly differently. You still set it up the same way, and I would start with the pair, sine of 71 over 21 equals. Well, we know the sides go on the bottom, and here's where sometimes people will mess up. They'll just put c on top. It's not just c on top, it's sine of c. So the difference here is that the variable is a little bit harder to get to than if I give you two angles, right? So does that change how you solve proportions? No, it's still cross multiply. That hasn't changed a thing. I'll still go 17 times the sine of 71, and it's going to equal 21 times the sine of c. So as I mentioned just a second ago, that variable's a little bit deeper in there. It is attached to that sine, which is a function. And so I would deal with the sine last. So let's get rid of the 21. How do you get the 21 out of this equation? Simply divide both sides by 21, because they'll cancel over there. So in other words, 17 times the sine of 71 divided by 21. Let's say that's a decimal, right? That's some number is what that is. And that's what sine of c is going to equal. And so I'm going to show you another neat little trick with the calculator that'll save you some time. So I'm going to write this one down. So 17 sine, we're going to go to the calculator and just type that in and find out what we get. So 17 sine of 71. Again, watch out, close off that parenthesis, and then divide by 21. Okay, giving everybody a chance to type that in that wants to, and you're going to want to once you see what I'm going to do next. So big, long decimal. I know throughout your math career, a lot of you have just written down that big, long decimal and then gone and done the next step. Well, do you agree that basically okay, not going to work for me. Anyway, that sine of c equals that decimal. Do I want to know what sine of c is? No, I want to know what just c is. So how do I get sine off of c? Arc sine. So in other words, I have to take arc sine of both sides, which means I have to take arc sine of that decimal you see right there. So instead of writing out that big, long decimal, you don't have to do that. If it's the last thing that was on your calculator, just go ahead and put arc sine up there. And all I need to do is get that big long. Could you sit there and just type it in right now? Sure you could. But all those calculators out there, Texas Instrument has this button that says ANS. That means answer. And what that'll do is it'll take the last answer it had and it'll put it in there for you. And so I think it is even on every calculator, it's on that little negative sign, isn't it? And so go ahead, hit second, that. And what it's going to do is it's going to take that decimal and put it in there for you so that you don't have to write that down every time. And of course you should be in degree mode because I want my answer in degree. There is trig involved, there is sine. And you hit that. Do you think this is going to be bigger than the 71 degrees for the other one or less? Less, yeah, the side's smaller. And apparently it's 49.9 if we round to the nearest tenth. And of course that is degrees. Any questions how I use the calculator on that one? Okay, nice little feature that they have. So 49.9, got it. So this one here is 49.9. Well, if I just asked you for angle C, we'd be done. Unfortunately, I asked you to solve the triangle. But there is a pretty simple one to find next, and that's angle A. So we've used 71 degrees, we've used 49.9 approximately, leaving how much for angle A? $59.1 degrees left over. So if you had to classify this triangle, you would classify it as acute and scaly because there's no way side A is going to be the same as any of the other ones. What about side A? Bigger than 17 or less? Bigger? Bigger or less than 21? Yeah, it should be between 17 and 21 somewhere based on the angles. Can we use Pythagorean theorem to find side A? We unfortunately have to go back to law of sines. And I would once again go back to the pair you were given at the start, because that's more accurate. The 49.9 is rounded, so you should try and avoid that if you can. Unfortunately, I can't avoid the 59.1. Over side A, because this is side A right down there. And so 21 times that equals A times that. The variable's a little bit easier to attain this time. Will we be using arcsine to solve for A? Will we have to do arcsine on this one? No, we won't need it this time, because we could just divide by sine of 71, because it's just a decimal, just in a weird form. And you told me between 17 and 21 somewhere, so hopefully that's what you come up with. It's almost smack dab in the middle. Comes out to be 19.1. So is the triangle solved? Yes, it is. Okay. Like I said, a lot of people, because this will work on right triangles too, so a lot of people kind of forego SOHCAHTOA at this point and say, I'm just going to use law of sine. And it works, as long as you have a pair and something else. So any questions about law of sines? Pretty nice. And really not overly difficult.